Hello and a warm welcome to our webinar 3D Printing in the Automotive Industry. My name is Kerstin and I'm the moderator of today's webinar. Here with me are my colleagues Christian and Jeremy, our experts for the usage of additive manufacturing in the automotive sector. In the following presentations, you will get some insights into how additive manufacturing simplifies your production, from functional prototypes to 3D printed interiors, spare parts, safety aid tools, and assembly fixtures. You will learn from real-life use cases and will see how a lattice structure can reduce the weight of interiors and enables customized comfort specifications and climate control. And now let's dive right in. Christian and Jeremy, please introduce yourselves.
Yeah, thanks, Kerstin, for the introduction. Also from my side, a warm welcome to our automotive webinar today. My name is Christian Reinhardt, and I'm responsible for business development in the transportation sector, especially for Europe, but I'm also involved in our activities in Asia. Today, I have my dear colleague, Jeremy, with me. Jeremy, can you please also introduce yourself?
Well, hi, Christian. Thanks much. And hi, everyone. Thanks for joining us today. I'm Jeremy Voss. I have commercial responsibility for BASF's 3D printing products and services in North America in the auto and transportation segment. And I'm looking very much forward to talking with you today.
Yeah, thanks, Jeremy. So let's have a quick look on today's agenda. First of all, we want to give you a short overview how 3D printing is currently used in the automotive industry. This is followed by how we as BASF Forward AM can support you in implementing or increasing your 3D printing activities. Afterwards, we step in some use cases, which we have done with well-known industry partners, also give you some more ideas in which fields or for which applications 3D printing can get interesting for you. And last but not least, Jeremy and I are there to answer your open questions. So no status report with some numbers. So let's start with this. You can see that based on the Volus report, the automotive industry is the top user of 3D printing. And when you now look on the right-hand side, you will directly understand why. The most fields of applications for which additive manufacturing is suitable can be found in the automotive industry. So you have prototypes, proof of concept models, production aids like jigs and fixtures, but also mass production like end usage parts. So now you may ask how a chemistry company like BASF can help you using 3D printing efficiently. We as BASF Forward AM access the market from two sides to implement industrial 3D printing. First, the obvious point, BASF produces and sells materials. Because 3D printing is still a quite new field, we have to figure out the customer requirements on the materials and find suitable material solutions. We support to qualify the products, go even into R&D to match the requirements when the current portfolio cannot do the job, and we cooperate with printer manufacturers to ensure a reliable part quality. The second field is the application development. We help our customers realizing their 3D printing objects with our large 3D printing material portfolio, our expertise in virtual engineering, like the well-known BASF UltraSim tool, as well as the decades of experience out of classical manufacturing from our mother company, combined with our 3D printing know-how. When we focus on the materials first, we can see here which plastics are already used for interior and exterior applications of a car. We can see a huge variety of different plastic materials. And now I want to show you for which plastic families we already have 3D printing materials in our portfolio. You can see these ones in the blue squares. Of course, when you, for example, focus on PA, you have hundreds of different polyamide grades, and in 3D printing, we might only have a dozen. But I would say it's already a good start. And still, even if a part would be manufactured in injection molding in polyamide 6, for example, in 3D printing, we would have to check if the 3D printing material is suitable for that, or we might go for another material for the same performance. Or what we also could do is a redesign to match the final part requirements. So again, that's why it's so important to understand the usage of the application. We as BASF Forward AM are no printer hardware manufacturer, so we rely on the printers which are available in the market to process our materials. Within the printer manufacturer landscape, there are actually three different approaches to the market. These approaches are really important to understand that you can figure out in which way and on which system you could process our materials. So first, we start with the open print systems on the left-hand side. There, it's easy to print our materials as long as the printer specs match the printing specs of our material. Two nice examples are here Fasoon for SLS, so selective laser sintering, and Ultimaker for FFF, so filament fabrication. But there are also way more manufacturers with open systems and which we also work together. The second pillar is that we as a material manufacturer start strategic cooperations with printer manufacturers. So you can especially recognize this when the materials are branded as enabled by Forward AM or enabled by BASF. Two nice examples are HP for multi-jet fusion or EOS with selective laser sintering. Last but not least, we have closed systems. So here the printer manufacturer is the only one selling materials for this printing system and also not doing any strategic cooperations. An example here would be the Stratasys printers. We unfortunately cannot access these printers with our materials at the moment. So let's move from the pure material side to potential applications for the automotive industry. I have clustered these applications in prototypes, end-use applications, and jigs and fixtures for production. Additionally, you can see these batteries indicating the technology readiness level of each application. So let's start with the prototypes first. I would say that the oldest usage of 3D printing is actually rapid prototyping, especially for design and appearance models. Our most published use case is actually the one in the middle of the left-hand side. It's the engine bracket, which we have developed together with Mercedes-Benz. The challenge here was how we can achieve the same properties than an injection molded part with a 3D printed one. Thanks to our virtual engineering colleagues and their UltraSim tool, we made it to solve this challenge. We'll take a closer look on the two other use cases later on. For the end-use applications, you can see two yellow batteries. So in this field, we see the highest challenges, but also the highest potential for the future. Especially the yellow use cases will also be presented later. If you maybe haven't seen it already, we also did a designated webinar about individualization a couple of weeks ago. In case you're interested, we can also share this link with you, or you can see it on our website. Last but not least, we have the jigs and fixtures with all different kinds of production aids. Here, our metal filament is worth to mention, that you can print easily and cost-effective parts on your desktop printer, send them to a debinding and sintering network, and then receive full metal parts printed in a 316L stainless steel bag. So now let's go a little bit more detailed into the use cases. So some of you may have heard of the cooperation in between Hymer and BASF. On K-Fair last year, the so-called Vision Venture concept motorhome was presented. In this motorhome concept were over 100 3D printed parts. One of them was the side plate you can see here. Especially when building up concept cars, you're struggling with producing the parts because it is lot size 1, and of course, there are no tools available. That's why 3D printing is really often used here. In most cases, the parts only have to look like the later on series parts, but do not have to perform as them. In the past, the printing of these parts was often really expensive, and normally these parts do not fall ready off the printer. With our materials printed on a photocentric Magna LCD printer, we made it to decrease the prices to about half of the cost in a comparable quality. When you think of this cost reduction for most of the printed parts used in a concept car, the overall savings are huge. Moving from an appearance prototype to a functional one, movement to e-mobility comes with a huge challenge for the industry. BASF SE offers great solutions in this sector for injection molding. Our colleagues at BASF Performance Materials contacted us if we have a solution for functional prototyping for inverter housing. And luckily we had. Standardly, these inverter housings are made out of aluminium. But even if aluminium is a quite light metal, a plastic version of it is about 50% lighter. But using a plastic result in another challenge. The inverter housing have to shield electromagnetic radiation. To ensure this, with the plastic part requires a metallic coating. There are a couple of technologies in the market how to metal coat the plastic part. For the technology used here, a high temperature resistant plastic part was needed. So this is actually no problem for the injection molding parts or materials, but a challenge for 3D printed ones. In 3D printing, widely used polyamide materials like PA11 or PA12 wouldn't survive the metal coating procedure. More ultra-thin PA6MF material has made it. So our colleagues at Performance Materials had a nice prototype, which they also could show around to customers and to prove the whole concept with it. And now I hand over to Jeremy for the next use cases.
Oh, thanks, Christian. Appreciate it. So I wanted to draw this application out first because this has a really significant interest for us. Our customer here was able to use the 3D printed containers to accomplish two unique tasks. First, they were able to print a bottle for design validation. So this bottle had complex internal structures, a novel shape, and custom fittings. So the second unique task that they were able to accomplish here was that the parts were able to also be used to validate the manufacturing process. So the printed parts were able to match up to the traditionally manufactured parts, and the two were actually able to be seamlessly welded together. The transition then from prototype to production and the validation that happened in between those cut months off of the time that was taken for design validation and actually increased the ability and the timeline on being able to start up the plant. So that's a really good example of a use case for fluid containers. On the next slide, we will look at an application that is particularly exciting, and I think probably the reason why a lot of us showed up today. It combines our printed TPU for the HP multi-jet fusion process and BASF's own UltraSim design service. So Ford came to us with a challenge to create a custom interior foam structure that can have tunable properties based on the needs of the model or the submodel. They wanted to be able to drill down even further on the individual responses based on where the part would be in the cabin and be able to do that all with lightweight and an open design that enabled comfort heating and comfort cooling as well. So our test-proven models of the TPU material enabled UltraSim to accurately predict the material behavior and to create custom lattice structures which were tuned to match the desired performance, even tuning performance to individual areas of the part itself. Our TPU is also very unique for the MJF platform in that it maintains mechanical properties over many build cycles in the MJF process. This enables production level solutions. This part was also very interesting as we walk through the process with production in mind. To create a part for the cabin, the material itself has to pass a battery of tests. The emissions of the material is an especially crucial factor. We don't want to breathe toxic gases or be surrounded by bad smells. Together with our partner Oshler, we have started the investigations in our UltraSim TPU material and its suitability for interiors. And together we figured out that yes, it is. Another piece of the car's interior is color, right? And so we've proven out the test cases for outgassing, and we're working on mechanical stability, and now we turn our attention to color. And so, you know, with polyamides, usually you would dye the part and to get good colors. With TPU parts, and especially gray TPU parts, that solution doesn't work for many of the desired colors. So we have developed, together with BASF Coatings, a special flexible spray coating for 3D printed parts. This coating is available in 4 different standard colors, and any other color can easily be developed on request. This coating has a great adhesion to the printed part and behaves exactly like the part. The 3D printed part in TPU and the coating pass the Rosflex test. Now this means that the part gets a cut and then it gets flexed and bent over 100,000 cycles. When the cut stays as small as it was before the test started, then the test passed. On the next slide, we'll see an example from our strategic partner in the US, Xtol. They specialize in creating unique ways to empower the plastics industry. One of their key products is a unique heat staking process called NanoStake. For this fast and efficient process, precise work holding tools are critical for repeatability and for protecting the finished parts as they're being assembled. Now, Xtol have begun printing the mating surface of their work holding tools, they call it soft touch tooling, out of the BASF TPU. This replaces a urethane molding process and significantly reduces the time investment that's needed for a new project. And it also lets them empower fast design changes for their customers. As we understand it, one design change iteration with printed tooling ends can save them $10,000 over previous methods. So that's a significant savings and a really neat prove out for soft touch tooling. Another interesting prove out has been with General Motors. GM has developed this application for printed polypropylene. Now they have a need to supply the market, or I should say they have a need to make available to the market a recall part for mid-90s pickup trucks. They expect to annually sell very few of these parts, but due to regulatory concerns, the part must be available. Now in the past, this part would have been designed and manufactured with a tool cost that we estimate above $15,000 and a minimum order quantity in the hundreds at least. And with a printed solution, GM has the part available for their dealers, but in digital form. So the part can be printed on demand and sent directly to the dealer for the needed repairs. GM is using this to prove out the viability of their digital inventory idea as they continue to grow in adoption of the additive manufacturing technologies. Now, BASF is developing a solution to empower manufacturers to efficiently handle digital spare parts as well. And Christian, would you please take us through that?
Yeah, thanks, Jeremy. What you also could see in the General Motors use case is that even a long time after the last car rolled out of the production hall, the spare parts for it have to be available. This causes, of course, extremely high costs and afford in warehouse and after sales management. One possible approach is, also like GM did, is to switch from a physical to a digital warehouse. And this is where Replique comes on the table. So Replique is another BASF startup, and they are focusing on how 3D printed spare parts can be manufactured decentralized by pre-qualified partners and ensuring that the partners cannot reproduce or copy the printouts illegally. So this software solution can be customized to exact the needs and integrated in actually every IT infrastructure. So it would be suitable for automotive, but also for other industries where spare parts have to be available a long time after a product runs out of actual production. So I hope that we could give you some interesting insights in 3D printing in the automotive industry, and you hopefully can connect with these to your own challenges which you're facing at the moment.
Thanks, Christian and Jeremy, for these insights. If you have any questions, you can approach our experts directly. You can find Christian and Jeremy's contact details on this slide here. And with this, I would like to say thank you, especially to Christian and Jeremy, but also to you, to our audience. We're happy to stay in contact with you. So thanks for joining and goodbye.